Now we're going to talk about domain and range again. Remember, domain is a description of all your possible x values and range is all your possible y values. But when you have a graph, there's an infinite amount of x values and y values. So what we look at is we're going to find the first x value of the graph. So when we have a graph, we're going to look and see how far it goes to the right and how far it goes to the left. If it has a stopping point that it only goes so far right, we're going to take a look at that. If it goes left and right in both directions, your domain is going to be all real numbers because it's everything. It covers the entire graph. For the range, we're going to look at up and down because y is up and down. So if your graph is always going up and down, for example, a line always gradually goes up, gradually goes down, so it would have a range of all real numbers. If it only goes so far down, for example, a parabola, or it would have its lowest point, if a parabola were pointing up, then we would look at what is the lowest y value there. So we're going to take a look at some graphs from what we had just talked about, and then we're going to talk about what is the domain and the range. So in this one, we need to look at, this is a cubic function, or a cube root function, so that was our S curve. Our starting point, since there is no number being added or subtracted inside the parentheses, would be at 0, -5, and then my slope would be that +1. So if I go over 0 and then down to -5, and then I have a slope of up 1 over 1, down 1 over 1, because we want to count it like a line for my S curve, and then I'm going to draw my nice smooth S curve here. Now if I want to talk about domain and range, D for domain, R for range. Remember, domain is your x values, which is your left and right. So what we want to look at is, does this graph always point to the left? Since it has an arrow, yes, this is always growing to the left. Is it always growing to the right? Yes, it is. So since it's going in both directions, it is all real numbers. Now for the range, we want to look at up and down. Now at the ends of a cubic, and I always tend to draw them horizontal, but they're not, they very slowly go down and very slowly go up. So it may not be going straight up and straight down, but it is very slowly growing down and very slowly growing up. So since it does point in both directions, your range is also all real numbers. And so that's your domain and range. It just means there is, your entire graph will eventually be covered with a line here. The next graph we want to look at here, we have a square root. So a square root was your curve that looks like this. My starting point, the number inside the parentheses, it says +3. So remember, we changed that to a -3. There is no number being added on the outside, so that's 0. And my slope is going to be the number in front, which would be a 2. So I graph at -3, 0. And then since my slope is 2, I go up 2 over 1 like I would for a line. Remember, since it has a starting point here, there is no dot that goes in this direction. And then I'm going to connect this with a nice smooth curve there. So let's talk domain and range. Domain and range. Domain is your left and right. So we look, does this graph go to the left? Well, my only arrow here is pointing to the right, so I would say no, it is not going to the left. So what we need to look at is, what is the x value at that point? In this case, your x value is 3. So what you're going to put it, or sorry, -3. An x and a -3. The way we write a domain is with an inequality, a greater than or a less than symbol. Since we are going to the right, that means it's going to be a greater than and also an equal to, because it can't equal -3 there. So my domain is x is greater than or equal to -3. Now my range is up and down. Again, I only have one arrow because I have a starting point. It only goes in one direction. This one is pointing towards going up, so that means I do not have an arrow that points down. Again, I look at this point and go, well, okay, what is the y value at that point? My y value, if you want to refer back to your starting point, was 0. And then since this is pointing up, that means y would have to be greater than or equal to 0. So if you notice, that starting point is going to give you
Mary Kavanaugh, please call extension 1000.
That starting point is going to give you, if it's not an all real number domain and range, it's going to give you your domain and your range. Your x value was the x value here, and your y value was the y value there. You just have to decide, is it greater than or is it less than? One last one to check. So we want to look at this one. This is the only time that we've graphed a cubic. So if you look back at your notes, that was the graph that did this. So it wasn't the S curve, it was straight down and straight up. Again, our starting point, the number inside the parentheses is a -5, so it changes to a +5. And then keep the -3. Our slope here is -1/2. So start at the point 5, -3, 5, -3. And then we're going to count the slope of -1/2. Since I have dots going in both directions, we count it like a line. So it goes down 1, over 2, up 1, left 2. And I'm not going to do the S curve. I'm going to go from the top here, follow along, and then go down. So that's how I graph it. Domain and range. Domain is your left and right. So is this always going to the left? Just like the S curve, it's not going totally vertical and totally vertical in both directions. It is slowly growing out to the left and slowly growing out to the right. So it is going both directions. So this is all real numbers. And then the range, remember, is your up and down. So I do have an arrow pointing up, I do have an arrow pointing down, so that is going both directions. So this is also all real numbers. Hopefully that's given you enough practice for your graphs and talking about domain and range.